Okay, so for the first question, we need to find the exact length of the curve y equals to x squared minus ln x over 8 from x equals to 1 to x equals to e. So we need to find the arc length. So we use the arc length formula. So arc length formula is s equals to integrate a to b square root 1 plus dy over dx square dx. So this question gives us the lower bound is x equals to 1. So we just plug x equals to 1 into this a here. So s equals to integrate 1. And the upper bound is x equals to e. So we plug x equals to e into this b here. So the upper bound is b equals to e. And we copy down the formula. 1 plus dy over dx square dx. And now we need to calculate the derivative of this function. And then if we can find the derivative and we calculate the integrate, and after that we can find the arc length. So first we need to calculate the derivative. So the original function is y equals to x squared minus ln x over 8. So we can also write it like y equals to x squared minus 1 over 8 ln x. 1 over 8 times ln x. So the derivative of this function is dy over dx. So the derivative of x squared is we put square in front, 2x, and 2 minus 1, minus the constant doesn't change, we put it here, 1 over 8, and the derivative of ln x equals to 1 over x. So we put that here, 1 over x, and so the derivative equals to 2x minus 1 over 8x. Okay, so now we get the derivative. So now we just need to plug this derivative dy over dx into this formula, the arc length formula. So s equals to integrate e to e, 1 to e, square root 1 plus, so dy over dx gives 2x minus 1 over 8x. So we just put 2x minus 1 over 8x into this formula. So 2x minus 1 over 8x, don't forget the square here, and dx. Okay, so now we just need to calculate the integrate, and we can find the exact length, arc length. So we need to simplify this. S equals to square root 1 plus, so this one and here is just like this. So a minus b, a minus b bracket square equals to a square minus 2ab plus b square. So 2x minus 1 over 8 square equals to, so the square of 2x is 4x square minus 2 times 2x times 1 over 8x equals to 2 times 2 is 4. 4 times 1 over 8 is 1 over 2. And okay. And we cancel out x here. We cancel out x here. So we get 1 over 2. So here is 1 over 2 times plus the square of 1 over 8x is 1 over 64x squared. So we change this into this here, 4x squared minus 1 over 2 plus 1 over 64x squared. So we write this at here, plus so these two are equal. Okay, so we still need to simplify this. Constant 1 minus 1 over 2 equals to 1 over 2 plus 4x squared plus 1 over 64x squared dx. Okay, so now we observe that this one, we can, for this one at here, we can combine these 3 terms into this form. So a squared plus 2ab times plus b squared equals to a plus b square, a plus b bracket square. So if we can combine these 3 terms into a times b square, and there is a square root here, so we can cancel out square root and square, and we just get and we just get the a plus b. So like a plus b square square root, we get a plus b. We get a plus b. So if we can get a plus b, and we can easily calculate the integrate and get the result. So let's see. Okay. Okay, so integrate e to e 1 to e square root 2x plus 1 over 8x squared dx. Why is that? Because 2x plus 1 over 8x bracket square equals to the square of 2x is 4x square plus 2 times 2x is 4x. 4x times 1 over 8x is 1 over 2 times the square of 1 over 64 x squared. So these two are equal. So we can change this into this form. Yeah. And now we can get rid of the square root and the square at here. So we get s equals to integrate 1 to e 2x plus 1 over 8x dx. And what I do here is I want to split these two terms like this, plus integrate 1 to e 1 over 8x dx. So we put the constant in front. So s equals to 2 1 to e x dx plus we put the constant 1 over 8 in front. 1 over 8 integrate 1 to e x 1 over x dx. And now we can use the fundamental theorem of calculus. The fundamental theorem of calculus gives us that part 2 gives us that integrate integrate a to b fx dx equals to the original function fx, the antiderivative of fx, we call it big F x, and upper limit and the lower limit doesn't change, and we plug upper limit into this big fx, get fb, minus we plug lower limit a into this fx, fa. So this is the fundamental theorem of calculus. So we can just use this theorem to calculate the integrate here. So s equals to 2. We need to calculate the antiderivative of x. So the antiderivative of x equals to, so there is 1 degree at here, and so 1 plus 1 and over 1 plus 1. This is the antiderivative of x, and we write upper limit and lower limit plus 1 over 8, the antiderivative of 1 over x equals to ln x, and we put upper limit e at here and the lower limit 1 at here. So we get s equals to 2 times x squared over 2 e1 plus 1 over 8 ln x. We still copy it down, and okay, so then we just need to plug the upper limit and the lower limit into x squared over 2. So we get 2 bracket e squared over 2 minus 1 over 2, 1 squared over 2 plus 1 over t. We plug upper limit e into ln x, we get ln e, minus we plug 1 into ln x, we get ln 1. Okay, so for this term at here, the denominator is the same, so we can combine these two terms together like this. E squared minus 1 over 2 plus 1 over t. So ln e equals to log e equals to 1, and ln 1 just equals to 0. So we get 1 minus 0. So s equals to, we cancel out 2 and 2. We get e squared minus 1 plus, so 1 over 8 times 1 equals to 1 over 8. So s equals to e squared, so minus 1 times 1 over 8 equals to